Thanks for joining us. Thanks so much for joining us. We hope that you are in the right place. As PJ already mentioned, this is getting started with ST Math for administrators. I'm going to situate my screen over here to make sure, but can you all give me a thumbs up if you can see a penguin staring at the sky with some constellations there, some math constellations? Perfect. Looks like you can see what I can see. Perfect. If you want to turn your screen on, I would love that because I do love talking to people and not to little black squares. But if for some reason you are in a place where you're like, you know what, it's been a week, I'm not turning my camera on, that is totally fine too. Or if you have other things that are going on, I totally understand that. So you can see my screen now. Let's start here. Tell me in the chat, what do you already know about ST Math? What do you already know about ST Math? And it can be anything. It could be nothing. It could be, there's a penguin. What do you already know about ST Math? Share in the chat with us. This is just going to help me to understand a little bit better about kind of where we're at as a group. Conceptual understanding. Students learn math through games and intuition. Pictorial to abstract. Great. It stands for spatial temporal math. Elijah, you're stealing some of my thunder. That's actually one of my slides. So that is good. All right, I have seen it from a parent perspective only. All right, well, this is going to be interesting then. Provides learning from a CRA model. Yep, so good. It sounds like we maybe don't know a ton about it. Tell me on a scale of 1 to 10, where are you at in your implementation? 1, we haven't purchased it, like we are not implementing. 10 is we've been implementing for 5 years or more and we're champions with ST Math, but I'm just new to the district or to the school and you need to get some information just so I can kind of see kind of where y'all are at. Or somewhere in the middle. Great. So maybe you've started an implementation. We're starting in summer 2022, first year implementation. Good. Okay. Now that we know a little bit about who's here, let me tell you a little quick thing. Just kidding. About me. So this is getting started with ST Math for administrators. We're at the Next Level Learning Conference, and my name is Melissa Galvin. I am an Education Success Manager here at Mind Research Institute. And if you're thinking Mind Research Institute, I thought we were at ST Math. Don't worry, Mind Research Institute is the nonprofit creator of the game ST Math. And so if you ever get an email from anybody who works for ST Math, you'll actually notice at the end of our email, it says Mind Research. Because we are an organization that cares very deeply about making sure that students learn math in the way that their brain will actually learn it and retain it. So here we go. We're going to play to discover how learning occurs in ST Math. We're going to talk about creating a GG culture with best practices and what some of those things are. We're going to learn to monitor our implementation, and we're going to discover some resources and support. And we are all going to do that in like 30 minutes or less, which means we're not going to get to everything because we did start a little bit late. So I'm going to go quickly. I promise to talk slower than normal if y'all promise to listen faster than you normally would. Can we do that? Okay, so sorry, I am a fast talker and I probably crammed 60 minutes of stuff into this 40-minute session, so we're gonna see how this goes. But feel free to stop and put questions in the chat along the way. PJ's here to help with those questions as well. And we can get going. So at Mind Research Institute, we asked this question: can a game change how you feel about math? And we believe wholeheartedly that it can, because we have seen it happen. We've seen it happen, both PJ and myself, here as employees of ST Math at Mind Research Institute, but also as educators ourselves. Before we made the switch over to the curriculum side of things, we both have served as principals and teachers for many years before we transitioned over. And so we both wholeheartedly believe this, and we think that if you can get into a good implementation, you'll be able to see this proof too. So again, Mind Research Institute, our mission is to ensure that all students are mathematically equipped to solve the world's most challenging problems. And how we do that is primarily currently through a game called ST Math. Now there's some new stuff on the horizon you'll hear about in the some other sessions, but right now ST Math, kind of our main product out there, is a supplemental math program. And so we're going to talk about kind of what that is today. As somebody already mentioned for me before, they know that the ST in ST Math stands for spatial temporal. So here's the question. Why would we name an entire program after spatial temporal? Why is that what we would call our game? And the reason is because we teach math the way that the brain naturally learns it, and that's using a spatial temporal approach. So let me explain what spatial temporal actually is, because it's probably a term you heard back in your master's program or whatever when you were in school at some point, but maybe haven't given much thought to it lately. So spatial
Oh, we lost Melissa there for a minute. Let me check with her. In the meantime here, just in case that you haven't heard, spatial temporal math has to do with how the brain functions and the way you see things in its more spatial way to do it. I'm texting Melissa on the side to see if she can come back in here, but do want to leave you hanging with that thought just for a second in case you weren't familiar with what the ST and ST Math was. Looks like she'll be hopefully logging back in. Anybody have this at a staff meeting, doing a virtual staff meeting, and you lose half your staff, or you're doing a presentation and it kicks you out or something? That's just the world we live in now. Yep, we can hear you, Melissa.
Okay, I don't know where you lost me, but all of a sudden I just heard PJ say something about, let me see if she can. And then I realized everybody's screen was frozen, which meant my screen was the frozen one.
Yeah,
so where did you
ST.
lose me at?
Yeah, we just went through the ST part, the spatial temporal part.
Okay, so did I explain what spatial temporal reasoning was, or did you hear my question?
I'd say between the two of us, we tag teamed it.
Okay, so I was asking y'all, when can you think of a time outside of ST Math where you would use spatial temporal reasoning? So that was kind of the question I had posed. Did anybody think of any good examples, or you probably didn't hear the question? Let's see, you can drop it in the chat if you think of a good example while I get my screen resituated here. When might you use spatial temporal reasoning outside of playing ST Math? Let's see. Now I just have to find my chat window again. There we go. Okay, sports, driving in traffic, puzzles, chess, perhaps. Absolutely, Carmen. Chess is a big one that I use a lot as an example. Loading the dishwasher. Kristen, I love that answer. I haven't heard that from somebody before, but right. So I always think of it, because I just want to give a very clear, specific thing. So let's use loading the dishwasher here. When you have a bunch of objects and you can see them in a big giant pile, and you see another space that you want all of those objects to fit neatly into, right? So the ability to manipulate those objects through space and time in your mind to figure out the best way to get it all in there. If you're going camping and you have a bunch of camping gear that you need to get in the back of your tiny SUV, that's another great example. You're manipulating those objects through space and time in your mind. Okay, y'all are still with me. You can hear me. You can see my screen that says spatial temporal math. Perfect, then we're going to keep on going. Maybe. Okay, so when it comes to spatial temporal math, I want us to take an example like this. So estimate the sum 7/8 plus 12/13. You've probably seen this question in a textbook somewhere along the way or something very similar to it. My question for you is this, drop it in the chat, A, B, C, or D. What did most students across the nation answer to this question when given this on a state assessment? A, B, C, or D. What did most students, not your students, I know your students would get it right, but what did most students answer this question? A, B, C, or D? C or D. So let me ask you a question now. You're telling me you're C or D, and we know, though, that that's not the answer. So my question is, why would the majority of students choose C or D? Have any of you ever in your education career, raise your hand, have any of you ever taught students that when they see a math problem like this, they need to add across the top or add across the bottom? Anybody? Have you ever taught your students that? Okay, so the reason here is because they add the numerator or the denominator, right? And so what they're doing is they're relying on memorized algorithms or processes rather than actually visualizing the math. So what we want is we don't want students to go into their brain and search in their file cabinet for a way to solve the problem. We don't want that. What we want them to do is come up with creative solutions. We want them to be mathematically equipped, not to memorize something that they would do. Earlier in James Tanton's session, he mentioned he had like 234 times 10. And he said he was taught to just add a 0 to the end. Y'all remember that example that he gave? And then he said, instead of adding a 0 to the end, he said, let's reveal the 0 at the end. That's kind of the difference that we're talking about here. We don't want students to just memorize that, oh, whenever something's multiplied by 10, we just add a 0 to the end of it, because that doesn't actually explain what the math is doing. We want them to be able to visualize the math. In this case, if students visually saw 7/8 and they visually saw 12/13, they could see that both of them are very close to 1. And therefore, the only reasonable answer is almost 2, right? So let's play an ST Math game here. I need, oh, in this case, PJ, I did need my notes. So let me, because I need the link to this. So let me get you this link real quick and I'll put it in the chat. And then I'm going to have you play this game. So here's a link in the chat. I want you to go ahead and open it up and play this game. And just take maybe 2 minutes or so. PJ, how much time do we have on the clock till our session is ending?
The session ends at 10:20. The next one begins at 10:30. So there's a little buffer there, but we want to give people a chance to take a break and, yeah.
So we've got 10 minutes. Okay, so I want you to take just 1 minute and play this game. This is a fractions game in ST Math. You've got the link there in the chat. And I want you to just play it for a quick minute.
So Melissa, we do have 20 minutes left of this session.
Perfect, thank you. I'm going to go ahead and play on my screen just in case any of you are having access difficulty. You can follow along on my screen. I'm not going to narrate what I'm doing. I'm simply going to play. All right, go ahead and come on back to my screen. You'll know you're on my screen when you see the static and the static picture, sorry, not static, the static picture with the balloons. And now you can see Gigi there on the cycle. So this is a game called Gigi Cycle. And I want you to tell me, what did you notice about spatial temporal reasoning? How did you see spatial temporal reasoning in this game as you played it or as I was playing on my screen? Go ahead and drop that in the chat for me. How did you notice spatial temporal reasoning playing out here? So it's kind of a trick question, hard question. Some of you might be typing your answers. Oh, yep, how the circle relates to the number line. Right, so we see the circle or the cycle that Gigi is on, and sometimes the cycle was a full wheel, sometimes it was half of a wheel, and we had to manipulate in our minds, where is that little penguin Gigi going to land? So let's move on here. The ability for students to manipulate those images in space and time is spatial temporal reasoning. And the reason that's so important is because students have to be able to visualize the math and what it actually represents. So Gigi is the penguin. You probably heard me mention this. And Gigi is our student ambassador who walks along this journey with students through their grade levels math curriculum to help them as they encounter hurdles. And the goal in almost every single ST Math game is to get Gigi completely across the screen. Now, sometimes, like the one we just played, Gigi's going to hop into a hot air balloon and go up off of the screen. But most of the time, the goal is to get Gigi from left to right. And we work through these cones, I call them cones in ST Math, but they're actually ST Math objectives. And these objectives here are very carefully scaffolded. And so every student's grade level journey is made up of these objectives that correlate back to their state standards. And then students have multiple games, each with multiple levels, that will help the student to complete that objective. Now, somebody mentioned this earlier when I asked you what you already knew about ST Math, and somebody had said, oh, it's very, I forget how you called it, pictorial to something else, but what we like to say is visual to symbolic. So here again, sorry for all the technical difficulties today. Let me get this so y'all can see what I'm talking about. And let me open this in a new link. Okay. So we're talking about visual to symbolic. And when we do, what happens in an ST Math game is we start off with a puzzle that looks something like this. There's no written instructions, so we don't have language as a barrier anymore. And we can now make it a lot more accessible to many more students. So we also don't have many math symbols in here, or any at this point, because we want students to be able to come in and use their one-to-one reasoning. So we start totally visual, and slowly we will start to add in those symbols. So eventually we get to a completely symbolic problem. And by the time we do, the students have recognized as they've moved through the sequence of puzzles that of course you have to know how many legs each animal has before you can identify the total number of legs. So now when a student sees this, the way that their brain would naturally just try and solve it, which sometimes when I ask that question, some students would say 2 + 2 goes first because it's easier to add. So I'm going to add the 2 2s in the middle first, and then I'll go deal with these multiplication things on the end, right? But a lot of students see this particular math problem and they would solve it in different ways. But a student who's gone through ST Math and has learned visually what the math actually represents will never make that same mistake because they know how important it is to solve in that correct order, because they know what the math actually represents. Okay, I think I'm going to skip this section for the sake of, no, I'm not. I'm actually going to jump in right here. Let's go. All right, so we're talking about how the brain learns. That's what I told you, the spatial temporal reasoning, right? So why is ST Math set up the way that it is? If we had a puzzle like the one that's about to appear on the screen, number one, there's no written instructions like we've already talked about. Because we want the students to think. PJ, are we still here? Okay, my screen just popped, so I wanted to make sure I didn't lose everybody.
No, still good.
Great. On this particular puzzle, we come into a puzzle and we don't know what to do. We're not given any written instructions because twofold, we don't want English language as a barrier, but also because we want students to have to think critically about what to do when they see a math problem, given novel situations. So we see this puzzle, and what do you think we're supposed to do? Somebody come off of mute. I might call on somebody, but it looks like some of you are also working at the same time, so I don't want to do that. Someone come off mute and tell me, what do you think we're being asked to do here?
We're trying to match with the image that's on the right.
Okay, so we see a grayed out penguin here, and then we see one that's face down, and we're trying to get this one to match this one. Is that what you're saying?
Yes.
All right.
So we have to rotate Gigi to get him facing the way he is on the right.
Perfect, Heidi. And so, Heidi, can you tell me which of these cards would you choose first if we need to try and get this penguin to match the other one? Would you choose card 1, 2, 3, 4, 5, or 6? Just for your first move.
For my first move, I want him to stand upright. So the first one.
Card number
To
1.
rotate him up. Yeah.
Oh, that didn't do what we wanted it to do. Maybe if we choose card number 5?
Well, it could still turn him. We could still rotate. Yeah.
Okay, so now that we're this way, Heidi, which one would you choose now?
The third card over.
Card number 3. And ta-da, we are there. Very good. Okay, so we completed that level. Now, on the next level, as we scaffold up, in this case, now we just solved it in 3 because I gave you some helps along the way for the sake of time. But had I not, it could have taken us 5 or 6 rotations to get there, right? Because we were actually working through the process of what is this card, what is this twist going to do, what is that turn going to do. In this particular sequence now, it only gives us 3 tries. So I'm just going to choose 3 random ones, see what happens here, because I intentionally want to get it wrong. All right, so we just learned from that. Now, if I do it correctly, let's see. There we go. We made it in 3 turns. All right, so what just happened is called the perception action cycle. It's a neuroscience term for you. I am not a neuroscientist, but there are many people who work here at Mind Research Institute who teach me a lot about it. So I'm going to share a little bit of neuroscience with you today and show you just kind of what's going on in the brain of the student as they play through an ST Math game. So given that problem that we just looked at, we come in and we make a prediction, right? Especially because there's no written instructions. This is the way our brain naturally learns, through this perception action cycle. We make a prediction and we took an action. We pressed the green go button so the action could play out, and there was an outcome. In this particular case, we got it right. And when we do that, our perception is fed information. So we have information that comes in and it sends signals straight to our hippocampus that then is going to reinforce the schema we already have. That pre-existing knowledge, what we call prior knowledge, right? That's our existing schema, what we already know to be true. Students come into lessons with schema that's already there. It might be all over the board, but they've got some schema that's already there. Now, when we go into a problem, if we rewind and try this again, and we actually get it wrong, I went through it pretty fast for you all, but when we get it wrong, there's still a prediction, there's still an action we took. The outcome is different. And so our perception, what we're seeing and what's getting sent into our hippocampus is different. This time, instead of building upon our existing schema, what we see happening is we're building new schema. So if you've been a teacher for longer than 5 minutes, you've been to a growth mindset training, right? And so growth mindset is all about this idea that every time we make a mistake, we're learning from it. That's exactly what you're seeing here. This is why when we play ST Math games, it's okay for students to get it wrong. We actually don't alert the teacher that a student has gotten puzzles wrong until they've gotten it wrong at least 9 times. 9 times, because we want the students to build their schema. It's all about building schema. It's not about getting the answer right the first time around. So how we do this is through the problem solving process. This is what's happening every single time that a student is going through an ST Math game. They come into the puzzle and we notice and we wonder what's on the screen. So we might say, what do we notice up here? We saw that there was a penguin that was grayed out. We saw some boxes along the bottom, right? And we wonder, what is it asking us to do? And somebody answered for me. We're trying to get that penguin to match that penguin. So we make a prediction and we justify that prediction. And then we test it and we observe it by pressing the green go button and letting the animation play out. As that animation plays out, that's that immediate informative feedback that's so important to teaching. And we want to analyze it and learn from it. And then we keep going through this cycle as the students learn how to solve this particular type of problem. So that's kind of the neuroscience behind why ST Math is set up the way that it is. This problem solving process is what we teach teachers in our introductory ST Math course for teachers in terms of how they should be approaching ST Math. So as this 3rd grader states here, Gigi doesn't just teach me, but teaches me to figure it out on my own. So the benefits of ST Math, you've probably noticed some of them along the way. Conceptual learning, again, we want the students to actually see the math behind what's being asked of them. It encourages perseverance because every time they get that immediate informative feedback, while that animation is playing out, they now see, oh, that's what I did wrong. Heidi, I think it was, who helped me by picking a card, and she said, I want Gigi to stand up. And so we picked this one card and it didn't work. It didn't get us the outcome we hoped for. But immediately we were encouraged to, we had that intrinsic motivation to say, oh, right, now I know what to do because I just saw it, right? It's accessible for language learners. It provides that immediate informative feedback we talked about that teachers wish they could give to all 20 students at one time. It is student paced, so each student is going to work through their journey at their own pace. It aligns to the standards, as I mentioned, as they go through all of the curriculum for their grade level, and it does include pre and post assessments for each one of those objectives. So lots of really cool stuff happening here. We've got just a couple more minutes, so I'm going to fly through these next pieces, but I will tell you the next few pieces that I'm talking about, there are multiple sessions throughout today where you can dive in deeper to any of them. There is a whole session on creating GG culture, for example. So dive into those if you want some more, but just real quick, time spent on ST Math is time spent learning. So we do have fidelity measurements and they look like this. These are our weekly recommendations. So kinder and first grade, 60 minutes for a completion of anywhere between 25 and 65 puzzles. Second through eighth grade, 90 minutes per week for an expected completion of 35 to 95 puzzles. Now, again, students are working at their own pace. So how many puzzles they complete is going to be dependent upon their prior knowledge and how quickly their schema is building as they're working through those things. All right, we do have many studies, and again, you're going to go to some data sessions today, I'm sure, at these other things, and we'll give you a whole bunch of data, but here's one quick snapshot of a study that WestEd did back in 2018 that found that schools that use ST Math consistently from the start of the school year for those fidelity recommendations that I just mentioned saw that they were outgrowing similar schools on their state assessment by 14 percentile points. And this, by the way, is not just like one school or one state. This is actually 239 schools, 42,000 students across 11 different states. So a lot of growth happening. And again, this is just one particular study that I'm calling out, and we have much more data if you'd like to see it. Another thing in terms of building GG culture is I just want to keep this recommendation out there. And again, you can hear more about this in other sessions, but we always recommend that students stay on grade level with ST Math. In fact, that guy, Brian, who jumped into the last session, was trying to share a video when James' whole like tech went down. Brian's doing a session later on the science of implementation, and he goes really kind of deeper into this idea of how it is that students in ST Math, even though they're testing 2 grade levels behind in their regular math class, can still be successful on ST Math on their regular grade level. It just takes them more time. That's really what it is, because again, we're building the schema. It's just going to take them a little longer to get there. And so he'll dive into that. Another thing to help you build GG culture as you go along is to create competitions and celebrations. And so right now we have one that we are sponsoring from ST Math that we put out all of the parameters around, and we provide prizes and things, called the Winter Waddle. We offer a lot of these, but we do see a lot of schools that come up with their own celebrations and their own way of encouraging GG culture. And we love when you share on social media those things as well. Now, the administrator console is where you log in as an administrator, whether you're a district level administrator or you're a site principal. When you log in, you can see your different classes here, and it gives you kind of a snapshot of what each teacher is doing, how many minutes, how many puzzles, things like that. But the thing that I think is most important, in my opinion, for administrators to know is how to get these reports without having to log in. You guys excited about that? Yes, please. I don't have time to log into another thing, right? Just tell me how to get the reports. So here it is. When you log into your account, up in the top right-hand corner, it'll have your name. And if you go down to where it says Quick Links My Account, you can then go down and you can see the weekly report, and you can toggle this switch on and off so that you get a weekly report automatically emailed to you that tells you how your school is doing. Yay. Then you don't have to log in all of the time. And it is important, obviously, that you know how to log in and you can access that information when you need to, but you can actually do that here and you can get some notifications as well. So
Can I ask a question?
yeah, I'm sorry. I'll come back in just a second for questions. So
Okay.
once you get, when you are able to log in, a couple things to keep in mind that you want to keep an eye out for is, do students actually achieve their minutes? Are they steadily solving puzzles at a typical pace? And are there any alerts where students are stuck? Okay. So we've got resources for you all over the place. We have an Academy page. We have an ST Math help page, and you can find that when you log in right up here next to your name where it says support. You can find the professional learning tab for the Academy and some asynchronous classes, or you can go to the help page and type in a question there. So I'm going to skip the brainstorming for the sake of time, and I'm going to jump right to questions. We've got just 1 minute. Who jumped in and had a question for me? Go ahead.
It's Heidi from Weymouth. We actually already automatically get those emails seeing how our district is doing. Did someone turn that on for us automatically, or
yes,
I think
a
it's
lot of
Erin
times
that sends them to us.
A lot of times somebody, your education success manager, might have turned them on for you. It just depends on if somebody in the district said, go ahead and turn them on for all of my district, they may have done that ahead of time.
Okay.
Yep.
Okay. And
PJ,
Irene, I can see Irene. Thank you.
Yeah. PJ, was there any other questions in the chat that I missed that you think we need to talk about?
No, I think we're okay there. I am going to put into the chat, though, just some plugs you can use for social media. If you see something today that you like, that you want to share, whether it's from this session or other ones, we do have the hashtag Next Level Learning, and we're on Instagram as well as Twitter. So like I said, if you see something that you like and you want to shout out for ST Math, that'd be awesome.
Awesome. Thanks, PJ. And if y'all don't mind, right before you leave, can you just drop in the chat one thing you learned for me? One thing that you're taking away from this session. I know we didn't have a lot of time together, and I know we had some technical difficulties, but I would love to know if there's one thing that was an aha moment for you or something new that you learned before you go. And then I think we've got maybe 5 minutes to get to the next session, and hopefully this one will be a little bit smoother transition. Awesome. Thank you, everybody, for coming.